That's wave. Okay, particle. That's a particle. Looks like a billiard ball. It is a billiard ball. Billiard ball is a particle. Well, it's a collection of a lot of particles. How do particles behave? Do particles behave in anything like the complicated ways that waves behave? No. Particles are easy. A particle at rest stays at rest. You put it down, you can wait for a good long time. It'll just stay there. So it doesn't radiate. Until something pushes it, now it's in motion, and it'll stay in motion until, boom, it runs into the stripe at the side of the screen, and it stops. If it was a different color stripe, it would probably have bounced off. When two particles meet, do they interfere? Well, I suppose you could call it interference. They bump into each other, and they do not otherwise interfere. Here it comes slowly. Oh my gosh, it's going to hit. Ooh! And there we have what will happen when they bounce off each other. Particles that hit each other, they bounce off. Okay, let's think about our wave tank and what happens when a wave went through the slits in the barrier. And here we have two slits in a barrier. And how is the particle going to get through? We don't have to think about this too much because there's two possibilities. It hits the barrier and bounces off, or it goes through the barrier and keeps on going. And here we have the result that's going to happen at the bottom. We see them piling up in pretty much straight lines. And so that's all there is to particles. They can hit and bounce off. They can go through and pile up. Nice straight line. Geometry is wonderful. That's all there is about particles. All right. Someone mentioned another kind of wave, a light wave. Interesting that you should think that light is a wave. Someone must have told you that. What's the other possibility? If light wasn't a wave, what would it be? A particle. Other possibilities? Silly putty, I don't know. Those are our basic possibilities. So we have the question that I'm going to present was, what is light? You've got one opinion that it's a wave. That's an ancient and honorable opinion. Has been held for many years, many centuries. Some people have thought that light was a wave, and there are certain reasons for that. Isaac Newton was one. Isaac Newton. We'll start with particles. Other people, also honorable people, we're not casting aspersions, have thought that light was a particle. One of the honorable ones was Sir Isaac Newton. He thought it was a particle. Why? Because light travels in straight lines. Sounds like a particle to me. And light bounces off of miracles. Oh, there's a miracle. Light bounces off of mirrors. Sounds like a particle to me. Anybody convinced? I should have at least a couple of hands out there. I mean, Isaac Newton thought they were particles. Other people, there's Robert Hooke. He thought waves. Why? Is there any evidence that light is waves? Well, yeah, there's some evidence. Is a shadow always sharp? It's not, actually. And even if you get a very good coherent light source, like a laser we have everywhere these days, it wraps around the corner a little bit. It actually does. So it doesn't have a clean edge to it. Here's this little penumbra, a little shadowy softness to the edge. So it's like it's wrapping around the edge a little bit, and that's what a wave does. When it hits the barrier, it starts to wrap around a little bit. So there's some evidence that light is a wave. Anybody think that light is a wave? There's a couple before. Also a very good, widely held opinion. Thomas Young, the inventor of Young's double-slit experiment. It was even named for him. He said, I'm going to decide. I'm going to make a test, and I'm going to find out whether light is a wave or a particle. Because I love Mr. Newton, and I love Mr. Hooke, and I don't want them arguing all the time. Let's find out. He says, I'm going to do a double-slit experiment. We just saw in a double-slit experiment that a wave going through a double-slit behaves very differently from a particle going through a double slit. You can't confuse them. One has undulations, interference patterns, spokes. You take a cross-section through it and you see the spokes, so you see stripes. The other, you get a couple of piles of particles. So imagine, if you will, shining a light through two slits. What are you going to get? There's a light bulb. There's a piece of paper or something with two holes in it, and then it's going to shine on a photographic plate. We'll call it a light detector, which is exactly what it is. It reacts to, when light hits it, it reacts. It has just detected light. Well, what are our possibilities? Here are the two logical possibilities. If Isaac Newton is right, we're going to get little spots of light, two spots of light. They go through the hole, and you can see the light back on the screen, on the photographic plate. That's if light is particles, that's what we will expect. If light is waves, we're going to expect something completely different. And you see that on the right side of the screen. We're going to expect to see a series of stripes. Why? Because if you look at those radiating spokes that you can sort of see on the graphic, they overlap, and then there's no overlap, and then they overlap, and then there's no overlap. So where they overlap, it's going to be a high, bright light. The light is going to be stronger. And where they don't overlap, there's not going to be any light at all. That's what we would expect if it's a wave. We would expect to see an interference pattern, and that's what it would look like. Okay. Well, we're in church, so I can't take bets. But those are both pretty plausible possibilities. He ran the test. And the result, stripes of light. That's what showed up on the photographic plate, on the film. Stripes of different widths. Well, the same width, but they actually get dimmer up here. They're brighter in the middle, and they get dimmer at the edge. Why is that? Well, if you look at our radiating spokes, you see that the point of overlap is going to be in the middle. So the point of most reinforcement is going to be actually in the middle. And then out here, they're more of an oblique angle. They're crossing not head-on, they're crossing more like that. So there's less of an area of overlap, and it's going to be a weaker reinforcement that the interference causes. So, and you see that, that's exactly what you see here. Weaker out there, strongest in the middle, and a series of stripes created by two slits. What's your conclusion? Is light a wave or a particle? I can't hear you. Thank you. Well, that's what everyone else concluded. In 1801, we had settled the argument. Isaac Newton, God rest his soul, prince among mathematicians and scientists. It turns out he was wrong. And he never actually said, I posited bet my reputation on it. But he thought it was particles. Turns out he's wrong. So everyone concluded that light is a wave. They were satisfied. This is a wonderful, wonderful experiment. I mean, it really was. It was brilliant. Who would have thought of that? There were two possibilities. I'm going to decide. He tried it. Clear result.